we've got Peter Lewin at SiFive.
Hi everybody. Okay, I think that's working now. Hi. Thank you very much. My name's Pete Lewin. I'm Director of Product at SiFive. I look after our essential range of embedded processors, and I'm really pleased to be able to introduce you today to the 4th generation of this Essentials product line. Just as a quick brief overview of what this Essentials product line is, it's actually 8 different distinct CPUs covering the whole embedded space. So down from the E range, which are 32-bit real-time processors, so really good for control and real-time applications, up to the S range, which are very similar. They have a lot of the same features, but that implements the 64-bit ISA, all of the S cores. And then when we move up to the U range, again, it's very much the same features, but that supports virtual memory addressing, so an MMU. They can run Linux. Yes, so the U series can support Linux and other operating systems like that because it has the virtual memory support. That's looking that way. As we go across the columns, the 2 series is the low-end performance point, which gives you really good optimized area, cost and power with a 2 or a 3-stage pipeline, depending on some configuration options. The 6 series steps that up to a much higher performance point, whilst again maintaining most of the same features, now going for a single issue 8-stage pipeline. And then stepping up to the 7, again, it looks very much like the 6 series, except it introduces dual issue, so about a 50% performance increase over what you get for the 6 series, of course with a power and area cost associated with that. So really good range from the E2 up to the U7, covering a wide range of applications. And there's so much commonality between all these processors. You'll see the Gen 4 applies to all of them. So the features I talk about later, it's an update to all 8 of these products. And the final point on this slide is that although I'm showing these as processor points, each of these is highly configurable. And it's not just cache sizes and things like that. There are microarchitectural adjustments. There's lots of different features that can be enabled or not. So the range is actually much more diverse than is really shown just on this slide. That's the range of CPUs that I'm responsible for and that we're focusing on today. But they don't live in isolation at SiFive. SiFive have these embedded cores, but then they also have a range of high-performance general-purpose CPUs and a range of high-performance AI compute as well. And these often work together, obviously, in an AI engine, and having that commonality of a lot of the features, a lot of the ways in which they're delivered, etc., really helps address an even wider range of performance points than I talked about earlier. There's really good traction in the market for SiFive's products. We've got more than 350 design wins. This is across most of the top 10 semiconductor manufacturers, across a whole range of applications, from automotive, storage, data center, aerospace, defense, and of course lots and lots of IoT applications. And they're shipping in volume as well. And I say volume, like we've shipped over 2 billion devices, or more than 2 billion devices have been shipped. We don't ship them ourselves. These are the sort of range of products that they're deployed in. These are all examples, real examples. So from mobile phones, like embedded controllers, not the main app processor generally, but embedded controllers and things like that in a mobile phone. Storage controller, for example, the SSD we've got there. A range of different networking applications. That's often where the U series comes in useful with Linux support. Right up to docking stations, and then even a smartwatch that features these CPUs. So they're really widely deployed in a wide range of different applications, really well tested. And these have really been in development for over a decade. Right, so from when our founders, who also developed the RISC-V ISA, first conceived of SiFive as a company, and SiFive was founded in 2015, work on these Essentials products started and have been continually improved and continually iterated on since. So this is where we get to the 4th generation today. It's really the culmination of all of that experience, all of that design work, all of that development over a decade. And we're committed to continuous investment and improvement in this embedded space. So looking a little bit at what the updates are, there's not like one big update that is characteristic of this fourth generation. It's really been worked on across the whole designs. They fall into four large buckets. One is improvements to performance, which have been made by improving both the level 1 and level 2 memory systems. We have code density improvements in there as well. There's a lot of optimizations to reduce power. Both general optimizations in the logic itself, and then also new power management features to take better advantage of clock gating, power gating, different power islands, different sleep modes, etc. We've updated everything to reflect a lot of the latest RBI standards as well. So the U CPUs conform to the RBA22 profile. We've introduced the hypervisor, WorldGuard security features, and other features, so really bringing them up to date with the latest specs. And we've improved the way they can integrate with the rest of the system through ACE support on the main memory interfaces for coherency, more CLPs, so core local ports, to allow more flexible interfaces to local memory systems for each CPU, and then just improve burst support on the buses as well. So, in summary, our Essentials range have been enabling embedded designs for a decade. They've been continually developed during that time. We continue to invest in this whole portfolio in the embedded space, where we know investment in other ISAs is failing. We have improved the performance, we've improved the power, we've improved the features, and we've improved the integration of these parts for the rest of the SoC. And that large configurability which we maintain and extend really allows chip designers to optimize each of those designs to meet their requirements precisely. So there's no wastage, you're not going to find features that you don't need or finding performance points that you don't need. All right, thank you.